Hey, hello class. So we're looking at part three of this trig lesson, and so we're looking asking the question like, where do we see periodic sinusoidal functions in the real world? And so here's some ideas. And so if you can check out these links here, um, and they talk about like tides in the Bay of Fundy, and so the x variable is actually time, and y would be a depth of water at a specific point, because it's gonna go in and out, and you're gonna see this going up and down, up and down, up and down with time, just rising and falling in a sinusoidal pattern. So this is one of the ways we see these, and we'll look at some more here. Here's an example. So it's a cyclical thing about jobs being available, and so you've got really an equation that's given, and so we really just have to interpret what the equation means, and we're going to graph it and talk about like what the key features are. And so the first one's the period. So we know that period has been compressed by 64.7, so it's actually 5.56. And since t is the number of weeks, like we're looking at 5.56 weeks. Um, and then the quadrants, that like the 90 degrees is actually now going to be 1.39. You can also do 90 divided by 64.72 to get that. But every 1.39, that's when you're going to hit like the top, the middle, or the bottom. Um, the amplitude's 4.1, so that's how much higher and lower you're going to go above the axis. And the axis is 5.8. So you can see the 5.8 roughly around there. 4.1 ahead, above, right around 9.9. That's a bit misleading. The 10 is actually above there. That point there is 9. So 9.9. And then 4.1 below is 1.7. So it's all going to stay within this little roadway here. And then since it's a sine curve, it is actually going to start in the middle here, and then go up. And we know it's going to go every 1.39. That's just what I used as the scale. It's kind of a funny, weird scale here, but I just used it so it's kind of a nice, we're only going to go on those lines there, and so it'll look the nicest. And it's going to start there, and it's going to go up just like some of the things we've seen before. And that's the graph. So most jobs available at any given time, you can see is like that 9.900, which is really 990. Which week will we have jobs be their lowest? Around week 4, 4.17. And then every 5.56 weeks after that, you're going to have 170 jobs. So in every 5.56 week cycle, around the fourth week is actually going to be the lowest. It takes 5.56 weeks to go through a cycle, and then the average jobs anytime is really just that middle number, which really is the average. It's that 580 jobs, the 5.8. Next example is temperature. So we're just kind of looking at curve of best fit here. So it's not actually going to follow it perfectly, because it's not a sinusoidal, like it is a sinusoidal situation, but this is just data. And so if you plot the data, the red guy really connects the dots, but this kind of blue guy will actually be what we're going to refer to as the curve of best fit. It's just like we have to kind of like follow a sinusoidal pattern, and just make sure that we go through it nicely. And so now the question is like, would you use a sine or a cosine wave? And you can use either or, and so this is the whole point of coming up with an equation. You can, in either or, you're going to have horizontal shifts, because month 1 is January, and so like month 0 is really like the previous December. So it always makes sense to do some kind of horizontal shift. So you could use a negative cosine curve and start down here, so shift it right 1. We could use a sine curve and shift it right 4. So like every 3 months is going to be the period. And so that's what the curve is for, is just to show like that max at 7, the minute, or the middle at 10 again, and the max at like 13, 12 months after. So every 3 months. And you can also use a cosine curve shifted right 7, a sine curve shifted right 4. A lot of different things that you could do there. You just have to make sure that you do kind of go through those 3 month bumps or as you hit the key points every 3 months. Um, so an equation to model the data. So we have approximately, um, I just wanted to pull up that blue graph. Approximately, amplitude is approximately 18. The period we know is 12. And so like the guy that you're going to be compressing 360 by is really 30. So if we divide 360 by 12, we can get 30. And then 360 divided by 30 gives you that 12 period. The axis is 0. It's kind of going up and over to the same point, and so right in the middle, the average temperature is 0. That point's a little off. It should be right around 10, and then 4 there. And if we use a negative coast curve, we just shift it to the right one, and then it starts at the bottom. We use a vertical reflection just to make sure we're starting at the bottom and not the top. Because remember, the cosine curve is the x values as you go around the circle, and so those should start up at 1 or like 18, and then get smaller after that, and then go down to -1. So the vertical reflection just starts them down at -1. So it's like kind of like it just starts at opposite. If we plug in month 20, we can just sub in 20, and you'll see 15.6. And that should make sense. Like it's a 12-month period, so it should be around the same as month 8. So 8 would be here is like around 15.6. You can see it makes sense. The reason why I say it's month 8 is because like every 12, the period's 12, so every 12 before it and above it are going to be roughly around the same. Okay. The last example here is a flagpole. This is just like a sinusoidal pattern of this thing going back and forth as it sways in the wind. There's a little bit of explanation here because it's just saying like, okay, assume it's so it's at its resting position, which is 0, and then it starts to move to the right, and right it says is plus. And so we are gonna like go start here, and we're gonna go up and then back and then down and then back. The big thing is it tells you it's like 240 times a minute. So we really got to find out how many times does it do, how long does it take to do 1. And so if we think like 60 seconds divided by 240, we really get like a quarter second per rotation. 4 times a second would get you like 240 every minute. And so 60 divided by 240 would get you that. And then if we divide that by 4, it's really every 6 seconds it's gonna like hit like a key point. And so that could be our scale. And so we start in the middle and then go back and forth. Then once we have the graph, we can actually create the equation pretty easily after that. So we've got the amplitude, we've got the axis of 0, we've got the period, so we can figure out the k value from 360. 360 divided by 0.25 is 1440, and it's just a sine curve. It starts in the middle, goes up, so there's no shifts or anything. And then the last question is just saying like, assuming that it goes the same speed, it just doesn't like kind of push it as far. It's just like it's gonna look like this, and so instead of to 10, it's gonna go to 8, and so the only change is really the amplitude. It probably would speed it up, or like if the wind speed changed, like it would probably slow down the period a little bit as well. But I just kind of kept it simple, like assume it stays the same. And then there's left like examples or questions for each of the parts of the lesson.